Hello and welcome. In this video I'm going to complete a series of tasks for segment routing on OcNOS devices. The task says, define a constraint under the policy created in previous task. ABC's traffic from R9 to R10 should traverse through router 4. Okay, so let me just explain what we have done before. In case you have not seen the previous video, you will have a clue. What we did is we just decided that we are going to have a dynamic policy, and with dynamic policy we can just decide, for example, IGP is going to tell which route is the best route to the destination. My ingress router is here, my egress router is here, and based on IGP, which is ISIS in my case, the metric for this link and this path, of course, and this path is the shortest, which is going to have only 2 hop counts to destination. I cannot explicitly say that hop count should be chosen as the criteria to decide what path to get to the destination, but of course I can just say that ISIS is going to make the decisions, and based on ISIS, of course, you know that because there is a default metric for each link, I can just decide what is the shortest path to destination based on hop count. But anyway, what we want to do here is this. So based on each one of these, you can see that under no circumstances router 4 is going to be the next hop to destination. And if I just try to shut down this link, which I have done in previous video, and if I try capture, you can see that Ethernet 2 is the best path to the destination. And I'm going to show you in a second. What I'm going to do is to say Ethernet 2 should be captured. And in the meantime, I'm going to go to router 3 just to show you the running configuration of interface ETH1. And you can see that ETH1 for now is shut down. And if I just go to router 9, which is this router on ABC, and try to get to the other ABC branch and create a traffic. So I'm going to say on router 9, I'm just saying ping 10, 10, 10, 10. I'm going to source it from 9999. And I can just say hit enter. Now you can see that the traffic is going through this link that I have just captured, which is Ethernet 2. But on Ethernet 3, if I just capture this as well, you would see that no ping is going to go through. So let's go back to the ping, and you can see that when the ping is running, there is no traffic going through Ethernet 4. All the traffic just goes to Ethernet 2. Ethernet 2. This one is Ethernet 3, sorry. Okay, so what I'm going to say is I'm going to define a constraint. Let me just stop this captures for now. Or let's cancel this and just go back to here. And I'm just going to stop them. I'm not going to close them. Okay, so what I'm going to do is to say, okay, I'm going to decide that IGP is the best way to take me to destination, but I'm going to just put some constraint on that. The constraint means limitation in this case. And I'm going to say, okay, instead of sending the traffic this way or this way, which is going to, find the best metric to destination, I really want to send the traffic to router 4. From router 4 on, everything is going to be based on IGP. And router 4 is going to use its IGP to decide where to send the packet to destination. So what I need to do is to say, okay, I'm using this interface IP address as my first destination, or I can even go with the loopback interface. If I go with loopback interface, there is no guarantee that the traffic goes through this link directly. We might even see that the traffic goes to R2 and then goes through router 4, which is not the best way, of course, but it might happen. And what I'm trying to do is to just say, okay, I'm using this interface IP address to get to the destination. Now, there are 2 types of constraints in this case. One of them is loose, one of them is strict. Now, strict says that exactly this IP address, and for that, most of the time, of course, the strict refers to a connected link. So, which means that I need to send the traffic right here. But loose says, okay, just this IP address. And most of the time with loose, we go with loopback interfaces. So in case, for example, I want to send the traffic through router 5, what I need to do is to say loose and then 5555, which is going to be my first destination in this case. And the traffic will go to router 5 most likely through this path, and from there router 5 is going to decide where to send the packet to get to its destination. So what I'm trying to do is to use the strict in this case, and of course, like I said, you can use loose, but loose in this case of course is not going to be useful for us. So let's just get to the configuration here. So on router 3, first of all, let's check the current configuration. Show run segment routing. Here you can see that I have defined dynamic path ISIS OE under candidate path 1, but there is no constraint here. So I'm going to get to this point. So let's go to configuration mode, and then I'm going to select candidate path 1. Under candidate path 1, you can see that there is an option for constraints. So I would say constraints and hit enter. Under constraints, I can say, okay, there is this ABCD, which is IP address. In my case, 4444 is going to be the loopback interface, or the IP address of this interface, which I'm going to use it, 10344 is going to be used for, let's say that. So I'm going to say 10344, and after that it says loose or strict. I'm going to go with the strict and hit enter. That is all I need to do for this, and I'm going to say commit. Okay, now if I say show run segment routing, you can see that now we have a constraint defined in here. Okay, so do I have anything under constraint that I want to configure more than that? Not really. I can choose metric type in case I want to go with PCE, but I'm not doing it right now. Okay, so now that I have done this, the rest of the configuration is already done. I have also, of course, attached this this policy to the VRF that connects to router 9. And if I just want to show you this, I can just say show run VRF ABC. You can see that there is a tunnel select policy. The name of the tunnel is dynamic TE tunnel, which is under this dynamic tunnel. So show run under this tunnel policy configured here, and the color is 1. This is exactly the color which is chosen for our purpose, which is this one, and it takes us to 6666, which is the other PE. Now let's initiate the traffic one more time, and now I'm going to capture Ethernet 2 and Ethernet 3. First of all, let's capture Ethernet 3. So right click here, capture Ethernet 3. So you can see now that the traffic is being sent through there. You can see that I'm just sending the traffic. You can see that the return traffic does not come through this way because this is not the best path to destination, right? This goes through this path, which has a higher metric. I expect to see the return traffic on Ethernet 2, which is a funny thing. You don't see any echo reply, right? So if you just check this, you can see the label stack on top of this. And let's go and capture Ethernet 2 just to make sure that we have guessed correctly. So if I just go to Ethernet 2 and check this here, for sure the return traffic, which is the echo replies, are coming back through there because that is the best path to us. And as you can see, if I just click on one of these, this is the label stack that is there, and it takes the packet to us. So with this, we have configured the constraint, and I'm just going to do something. I'm going to say router 3 interface EAT1. I'm going to say no shot, and I'm going to say commit, and I'm going to see the result of this configuration. The ping is still going through without any problem. As you can see, this is sending the traffic, and this is receiving the traffic. And if I just capture Ethernet 1, there should be no traffic on that for sure, which is completely correct. So with this video is going to finish. I hope this has been informative for you, and see you in next videos.